Hello and welcome. So this is part 3 of a problem that we started. We were given this really simple Cobb-Douglas production function, like a parameterized Cobb-Douglas production function. We found out what total output was equal to. Oh, I forgot to put that in here. So total output was 100. We found out the wage rate was equal to 0.5, and then we found out the rental rate of land was 0.5, and then we found labor share of income was 0.5. If you're not sure what any of those things are, I'll put links in the video description to the previous 2 parts that have led up to this problem. In this video, we're going to solve the last 3 parts. So part D, actually part E and F kind of build off part D, but part D is if a plague kills half the population, what is the new level of output? And then we'll also find out the new wage rate and the new rental rate of land, rental price of land, and then we'll also see if the share of output that labor receives has changed. So part D, we have a plague. What's new output? Well, it's pretty simple. We just need to use our production function here. So y equals this guy. Given these inputs, what is output? K is we're told is the same, or in the sense that we haven't been told that it's changed at all. So we're going to leave capital at 100, raise it to the 1/2, so we're taking the square root of 100. That's 10 already, hopefully. And labor has changed, so labor is now 50. So I'm going to, just to kind of show change, I'm going to add little subscripts. So it's now y sub naught, indicating the first one, and then L sub naught. So our new output after the plague, I'm going to put a little subscript of sub 1 just to kind of indicate that it's it's changed. And then labor, the new labor is 50 instead of 100, so I'm going to have a little subscript to indicate that. So plugging this in, let's see what that is. So the square root of 50 is 7.071, and then times the square root of 100, so times 10. So this times 10 is 70.71. So our new output, y sub 1, is equal to 70.71. Very simple. Remember, output originally was 100, and we've had, so intuitively, right, output was originally 100. We've killed off half the population. The population is now 50. So obviously you would expect output to decrease quite a bit. So output is decreased from 100 to 70. Awesome. So that's out of the way. Let's do part E. What is the new wage rate and the new rental price of land? So remember in the previous video, I think the first video, we found out that the wage rate is equal to the marginal product of labor. And the marginal product of labor was, we just took the first derivative of our production function with respect to labor, and we found the following equation. Actually, we had a simplified version. Let me show you the simplified version. K divided by L. If you don't remember how we got that, again, have a look at the video. So the marginal product of labor, which is the real wage rate here, is 1/2 times K divided by L, all raised to the 1/2. K is still 100. Labor is now 50, and then raised to 0.5. So let's figure out what that is. So we got, so 100 divided by 50 is just 2. So the square root of 2 is 1.14 times 1/2. So again, 100 divided by 50 is 2. The square root of that was the 1.4 something, and then all of that times 1/2 is this number right here, 0.7071. I'm just going to simplify to this number. No, I'm going to go a couple out. Okay, 0.707. So that's the new wage rate. And then what's the new rental rate of capital? ooh, I should do a little subscript. Bam. The old wage rate has a not subscript. The old rental rate of land has a subscript there. So the new rental rate of land is going to be equal to the marginal product of capital, which is a similar equation to this, but slightly changed. If you don't remember how we found that out, have a look at that previous video. So now just plugging in the numbers that we have for labor and capital. Labor is 50, capital is 100. And then what is this equal to? So 50 divided by 100 is 1/2. The square root of 1/2 is this number, and then times 1/2 here is equal to 0.3535. So the new rental price of land is 0.3535. So let's go through intuitively. We killed off half the population, so labor has gone down. Labor went down, was halved, so labor is more scarce now. And so it's reasonable, given everything else is equal, that the thing that's more scarce, labor in this case, the price of that is going to go up. So the wage rate has gone up because labor is more scarce. You could also think of solving that given just a supply and demand framework. So if you want to think of this as like a demand and supply for labor, this is like a market for labor here. By killing off half the population, that's an inward shift in the labor supply curve. Bam, inward shift. So what happens when you get an inward shift? Well, obviously the quantity supplied of labor, or the total quantity of labor, is going to decrease. So going from this point to this point, and then the price is going to increase. So before we had an equilibrium price down here, our new intersection has this equilibrium price over here. So however you want to think about it, labor is more scarce, and so it's more expensive. And then you have a similar story with capital. Capital is just relatively less scarce, and so the value of capital, the price of that firms are willing to pay capital, is going to go down. It was 1/2, and now it's 0.3535. Wages were 1/2, and now they're more expensive at 0.7. Cool. So that's E. And lastly, part F. What share of output does labor receive now? So in the previous video, the one just before this, I walked through 2 ways to solve it. So I'll do the second way in a second. I'll do the kind of longer, slightly more tedious way first. Okay. So what share of output does labor receive? So what's the share of output? So labor share of output, that is equal to, I'm going to call it labor share of output, I don't know, for lack of a better name. That is equal to all wages paid to labor divided by output. Okay, so in the notation that we have, all wages paid to all labor, what is that? That's the wage rate, right? And we have a new wage rate, times the quantity of labor, and we have a new quantity of labor. And then what is output? Output is just, remember, Y. It's like production, and we have a new output there. So let's just plug in our numbers that we found. So the new wage rate was 0.707. Remember, this is post-plague, so before labor was 100, now labor is 50. And then before labor, before Y, output was 100, now output is 70.71. So solving this through, if you just look at it, you might actually see what the answer is, but I'll use a calculator. So you got 707 times 50 divided by 70.01. So 0.4999. So I'm going to just round up to 0.5. So labor shares of income is 0.5. If you recall, this production function that we have here takes the form of a Cobb-Douglas production function. This is like a partially parameterized Cobb-Douglas function. Ooh. This guy right here, partially parameterized Cobb-Douglas production function. And so the exponent that's above labor, that's the share of production that goes to pay labor. And then the exponent above capital is the capital share of income. So I could have just looked at this and immediately known as 1/2. Before this plague, in which we killed half the population, the labor share of income was 1/2. Post the plague, labor still receives 1/2. The reason why is labor share of income is simply a function of this exponent and nothing else. So, you have to change that exponent in order to change labor share of income. So, I could have told you before, without doing all of this, that labor share of income was 1/2 because, again, the exponent above it didn't change. That's what is the labor share of income. And that's a particular property of Cobb-Douglas production function that's only specific to Cobb-Douglas production function, given its constant returns to scale. Okay, so hopefully that was helpful. That's chapter 3, problem 2, or problem 1. Yeah, hopefully that's helpful. Let me know if you have any questions. Thanks, and have a good day. Bye.